Okay, so let's solve this problem. Cannon fires a ball off a cliff with a height of 100 meters at 30 meters per second at an angle of 20 degrees. Find the time taken for the ball to hit the ground. Okay, so here's our cliff. It's 100 meters tall. This ball is fired at an angle of 20 degrees to the horizontal at 30 meters per second. Okay, so I would imagine the ball carries on like this for a bit and then carries on parabolic curve into the ground down here. So I've got to find the time taken. The first thing to recognise is that in any kind of projectile motion question you can treat the horizontal and the vertical components of velocity completely separately. So the first task for me is to split the vector for the velocity into the horizontal and vertical components. Okay, currently I'm only going to use the vertical component just for the part 1 to the question, but I can see that, assuming that that question is written down correctly, that the I'm going to need the horizontal component later as well. Alright, so I want to find this component here. So if this triangle is labelled up hypotenuse, opposite, adjacent, I can use sine to find the vertical component. So sine 20 would be equal to the opposite divided by the hypotenuse. So if I do 30 sine 20, I'll find the opposite. So 30 sine 20 is, just work that out, 10.2 meters per second. Okay, so this is actually what I'm going to use to calculate the time, but since I'm here I may as well calculate the value for the adjacent or the horizontal component of velocity. So I'll be using cos 20 equals adjacent over hypotenuse, and the same again, bring the 30 up, 30 cos 20 will get me 28.1 meters per second. So this is vertical, this is horizontal. Okay, so now I can go and think about finding the time. So I'm only thinking in the vertical only now. So suvat, and this is just for vertical. Okay, so I know that if the ball goes up and then comes back down again, if we're talking about displacement, its final displacement just in the vertical, it will have gone up and come back down. So if it went up and came to here, its displacement 0. If it carries on down to here, it's got a minus 100 meter displacement. The initial velocity in the straight up direction is 10.2. I'm keeping it as positive because I'm counting up as positive, down as negative. If my displacement ended up being higher than where it started from, I'd have counted the s as positive as well. V, I don't know the speed at which it's going to hit the ground, so that's not known. Acceleration is in the opposite direction to my velocity, so it's a negative value of 9.81 meters per second squared. And the time is the thing I'm looking for. Right, so I can use my equation from the Suvats. S is equal to ut plus half at squared. I've got s minus 100. I've got u 10.2 times t plus half. Now it's 9. It's 9.81, but it's minus 9.81. Mustn't forget that. Minus 9.81. Times t squared. Okay, so the problem now is I've got t and t squared, which means I'm going to have to use a quadratic solution. So if you get your quadratic equation, as you'd look it up in a textbook, or if you're like me and you've forgotten these things, you have to look it up online. Okay, so I need to get this equation to look like this equation. So all I need to do is add 100 to both sides, and I can just chunk this down, simplify it. So if I add 100 to both sides, the 100 will be on this side. It will be equal to 0. 10.2 t plus, if I do the half times 9.81 now, that's negative 4.905 t squared plus 100. Okay, so now subbing that into my quadratic formula, which is something again you might be familiar with from your maths equation sheet. Okay, so if I substitute the values in and calculate it, I'm going to get, well, that's B, that value is A, that value is C. Okay, and the T is my X, isn't it? So I'm working out the T value, and I'll get two values and have to decide which one's the correct one. So I'm going to do minus 10.2 plus minus the square root of 10.2 squared. Now, it is minus 4.9, and since I'm minusing it anyway, I'm going to have to, it becomes addition, so it's going to be plus 4 times 4.905, so I've already dealt with the fact that it was a minus here, times 100, and then divide all that by 2 times 4.905. Okay, now if I crunch through this and calculate it, I get two values. Okay, nearly made a mistake again here. The 4.905 is actually negative. Okay, so if I'm very careful with my pluses and minuses, as I work through this, I get two different values. Okay, so I get a value of minus 3.59 seconds, and I get a value of positive 5.67 seconds, and it's the positive value I'm interested in. The negative value is at minus 3.59 seconds. The ball would have been here if it was following this perfect parabolic trajectory. Okay, but we know the ball started here, and we're only interested in events that are happening in the future. So it's the 5.67 value I'm going to use. So this is the correct value for the time. That's part 1 answered. So let's move on to part 2. Find the distance taken for the ball to hit the ground. I think it means find the distance or the range of the ball. So I think it's asking me for this value. So let's go back to the idea of I can use the horizontal component separately, as though horizontal and vertical components of velocity are separate. So let's do part 2. Part 2 is pretty straightforward. It's just going to be, if I know something's moving for a set amount of time at a set velocity, I can work out how far it's gone. Speed equals distance divided by time. Distance equals speed times time. The speed in the horizontal only is 28.1. Whoops, 28.1, sorry. The time it is moving for is 5.67. So how far will it go? 28.1 times 5.67. And I'm getting 159.327, so I'll just leave it 159 meters. Okay, so I'll come back to part 3 in a minute. Okay, so just part 3 of the question now. Find the velocity of the ball at 2 seconds after launch. So let's just remind ourselves the ball has done something like this. Okay, and we want to find out 2 seconds after launch what its velocity is. Okay, so we have to remind ourselves that the velocity is made up of 2 components. I know that the horizontal component, as I've shown earlier, is going to be 28.1, and it will stay constant, right, if we can ignore air resistance. It's the vertical component that I need to worry about. Okay, so if I think just in the vertical, SUVAT, I don't know how far it's going to go. I do know that it goes up, it leaves at 10.2 meters per second. Okay, I'm trying to find out its velocity in the vertical only in 2 seconds time, right? So I can add it to the velocity in the horizontal, so I can determine its actual velocity vector. So I don't know its velocity yet. I'm hoping to find that out. Acceleration, again, it's 9.81 and negative for the reasons explained previously. So when I look at my Suvat equations, I've got V equals U plus AT. Okay, the initial velocity is 10.2. plus minus 9.81 times 2. Okay, so when I calculate that, I get minus 9.42 seconds. Sorry, 9.42 meters per second. Okay, so now when the ball has got to, well, I'm assuming since it left at 10.2, it's going to be just a little bit higher here. Its horizontal component of velocity is still going to be 28, and its vertical component of velocity is going to be 9.42. So if I just sketch those, okay, we've got 28.1, we've got 9.42. What I need to do is add these together and find the magnitude of this velocity. It says find the velocity, so I should really find the angle as well. But I'm just going to do the magnitude and leave it at that. Okay, and be a bit lazy. Right, so I can use Pythagoras, a squared plus b squared equals c squared. Okay, so I'm just going to do the root of a squared plus b squared to find c, which is the hypotenuse in this case. So that will be the root of 9.42 squared plus 28.1 squared, and having calculated this just a second ago, 29.6 meters per second. That is the magnitude of the velocity. If you want to go ahead and find out the angle to the horizontal, you can use trigonometry to do that. In fact, I might just do it. Go on, hypotenuse, opposite, adjacent. So let's use 28.1 as one of our values because it's probably one of the more accurate ones. So I'm going to use the adjacent and the hypotenuse. So that's tan theta equals adjacent over opposite. So adjacent over opposite will be 28.1 divided by 9.42. Okay, so 28.1 divided by 9.42. Okay. I've got these the wrong way around. Alright, that should have been 9.42 over 28.1. Let's do that again. 9.42 divided by 28.1. Shift tan answer. Okay, so it's saying 18 degrees. Okay, 18.5 degrees, or sorry, 19 degrees. Right, so we're going to say theta is 19 degrees to the horizontal. So we've got everything. We've got the velocity, and we've got its direction, so we've got, well, the velocity. Okay, I hope you found this useful. Thanks for watching. Any comments, make them.